Hello, this is Mr. Wynn, and now we have lesson 10-5, recursion and iteration. So there are special sequences that are neither arithmetic or geometric. A famous one is called the Fibonacci sequence. It's 0, 1, 1, 2, 3, 5, 8, 13, and then 21, and then 34, and it goes on forever. And unlike the explicit formulas for finding a term in arithmetic or geometric series, where we could just plug in n and get the value directly, the Fibonacci sequence will need a recursive formula because it's a recursive sequence. In a recursive sequence, each term is determined by one or more of the previous terms, and the initial term must always be given with the recursive formula. So just to test out fast, let's check if this is arithmetic or not. To go from here to here, I had to add 1. Then here I had to add 0. Then from here I had to add 1. Then add 1. Then add 2. And that didn't work. So that's not arithmetic for sure. Geometric's a multiplier. Well, 0 times anything is 0, so that fails too. So again, it's not arithmetic or geometric because we can't find something to add or multiply each thing. We have to find, like I said, a different formula, recursion. It uses previous terms. Here's the actual formula. The formula for Fibonacci is a sub n equals a of n minus 2 plus a of n minus 1 with the initial terms given. A sub 1 is 0, a sub 2 is 1. So let's plug it in and check. Say I want to figure out what a sub 3 is. A sub 3 means a of 3 minus 2 plus a of 3 minus 1. Well, a sub 3 minus 2 is a sub 1 plus a sub 2, which is a sub 1 is 0 plus 1, which gives us 1. And that is a sub 3. So the third term is 1. And again, this is the previous two terms added together. So 0 plus 1 is 1. Then if I want to add 1 plus 1, I get 2. If I add 2 plus 1, I get 3. Let's repeat. 3 plus 2, I get 5. 5 plus 3, I get 8. 8 plus 5, I get 13. Like so, the next term is going to be 13 plus 8 gives us 21, and so on. So you need the previous numbers. There's no set number to add or multiply by. It's a recursive formula. Let's leave that there. Alright, so with recursion, you must know the previous number or numbers, depending on the formula, and just plug them in. So here's the first example. Find the first 5 terms of the sequence where a sub 1 is negative 3, and in the formula a of n plus 1 is equal to 4 times a sub n minus 2, if n is greater than or equal to 1. Alright, so we have our first term. Let's find a sub 2. A sub 2 would be, I'll do it like this. So to get a sub 2, we're going to let n equals 1. So I'm going to do this. Let n equal 1. Well, that means I plug into the formula. It'll be 1 plus 1 equals 4 times a sub 1 minus 2. So this means a sub 2 equals 4. A sub 1 they gave us was negative 3 minus 2, which if I compute, that is negative 12 minus 2, which is negative 14. So we found the second term. Now we're going to look for the third term. So to find the third term, I'm going to say let n equals 2, meaning, like this, a of 2 plus 1 equals 4 times a sub 2 minus 2. So that means this is a sub 3 equals 4. Well, a sub 2 we just found was negative 14, so I use that answer, the previous number, minus 2. If I compute that, let's see, negative 28 minus 2, that is negative 30. Actually, I just caught myself. 4 times negative 14 is not negative 28, I did times 2. It's negative 56. So negative 56 minus 2 gives us negative 58. There's our third term. Let's find the fourth term. So we're now going to, use red, let n equal 3. So I use the formula. It'll be, let's stay red. A sub 3 plus 1 equals 4 times a sub 3 minus 2. And hopefully this time I won't mess up. So this is a sub 4 equals 4 times a sub 3, which found was negative 58 minus 2. Alright, for this, let's use a calculator. That gives us 200, 1 second, calculator. 4 times negative 58 gives us negative 232. Minus 2, that's negative 234. 234. And we just repeat that process. I plug in n equals 4 to find the next term. But we'll stop there. Alright, so side notes, arithmetic and geometric sequences can also be written as a recursive formula, though there isn't a real need to use this over the explicit formulas. But if you're curious, for the arithmetic sequence, the next term is equal to the previous term plus the common difference, which you know is you just have to add that number. In a geometric sequence, the newest term will be the previous term times r, because that's to multiply by something. Alright, so in order to find the recursive formula, first determine the initial term, then evaluate the pattern to generate the later terms. The recursive formula that generates a sequence does not include the value of the initial term. So, here's the first one. Write a recursive formula for each sequence. This first one, we have to figure out whether it's arithmetic or geometric or neither. We're going to do a check. There's a common difference, d. 10 minus 2 is 8. Okay, that's good. I'm going to see I'm adding it to 2 plus 8 is 10, 10 plus 8 is 18, 18 plus 8 is 26, 26 plus 8 is 34. Great. So we know d, our common difference, is 8. Alright. That's all you actually need for the recursive formula, because the recursive formula right here, the new terms is the previous term plus the common difference. So if you want the recursive formula, this one helps if you know the previous term. We know a sub n is equal to the previous term plus the d, which we know is 8. Now we do need to give initial term, so we define a sub 1. So to figure out a sub 1, we figure out it's right here, 2. Also a sub 1 equals 2. And we can check. If I plug in 2 to find the first term, we have the first, let's find the second term. So a sub 2 is equal to a of 2 minus 1 plus 8. Okay, I'm just checking. This is really a of 1 plus 8, which a of 1 I told you was 2 plus 8, and that gives us 10. So that's how recursion works. If you know the previous number, the previous answer, you plug it in, you'll get the next answer. But you have to know the previous one. If you don't know the previous one, then you're kind of out of luck. Alright, so we'll do the same thing for B. We're going to see if it's arithmetic, geometric, or not. Let's try subtracting, see if there's common difference. 56 minus 16, that is plus 40. 56 plus 40 is 96, that's wrong. Nope, not common difference, not D, not arithmetic. Let's try geometric. If I do division, 56 over 16, that does reduce. That is 7 over, not 7. Let's see, I divide that by 4, that makes it 16 over 4. Alright, reduce 56 over 16, I divide 8, so 7 over 2. So that looks like my multiplier. I'll try the next one. 196 over 56. If I do 28, I also get 7 over 2. So it's the same. I multiply 7 over 2. 196 times 7 over 2 is 686. Good. 686 times 7 over 2 is 24 over 1. That's good. So this is definitely geometric. We know R equals 7 over 2. Alright, I'm now going to use this in the formula. Remember, if I go back, the newest term is R times the previous term. So my formula is going to be A sub n equals R times my previous term. Now I have to give you the initial number, and that is A sub 1 equals 16. So here's the equation for the second one. Here's the equation for the first one. Let's box it in. We can plug in check, but I'm not going to. Alright, and this last one down here, They give a sub 4 and they give r equals 3. Well, if they give us r, that means it's geometric already. So we know r equals 3. We're going to write the formula. So it's going to be a sub n, I'll use black again. A sub n equals 3 times a of n minus 1. And now I got to find the first value. A sub 1 equals, we don't know. Well, that's why I do some math. So we plug in a sub 4. So here, a of 4 will equal 3 times a of 4 minus 1. Well, we know a sub 4 is 108 equals 3 times a sub 3. So if I divide what's by 3, I get, let's see, 108 divided by 3, calculator, 36. So now I found out that a sub 3 is 36. Then I'm going to repeat the process. So a sub 3 equals 3 times a of 3 minus 1. So that makes this, a sub 3 we found was 36 equals 3 times a sub 2. I divide what's by 3. I get 12 equals a sub 2. Alright, I found a2. I gotta find a1 now. So I'm going to go over here, repeat it one more time. So a of 2 equals 3 times a of 2 minus 1. A of 2 we got was 12 equals 3 times a sub 1. If I divide by 3, I get 4 equals a sub 1. So, what are 16 right here? Oh, there you go. So right here, a sub 1 equals 4. Alright, so there's a lot of work to go backwards. If we use explicit formula, it'd be a lot faster. Alright, here's a real world example. Use a recursive formula. Very big with loans. So Nate had a $15,000 loan. He has an interest 2% each month. He pays $400 a month. Write the recursive formula for the balance. Determine what balance is after 5 months. So you can read this, but it's initial balance plus balance times 2% minus his monthly payment. And once you have that new number, you're going to plug it in, see what the next month is, and just keep doing that. Because your new balance is what they charge you interest on, not the original. Now, one big takeaway is this. He starts out owing $15,000. After 1 month, he pays $400. So some people would think, oh, if you pay $400 off, that means there's only $14,600 left over to pay. But no. Of the $400 you paid, only $100 went to the principal amount. The extra $300 went to interest. So you lose a lot of money because of interest. So when it's a big amount, most of your money goes to interest and not to the principal. All right. Iteration is a process of repeatedly composing a function with itself. So we've done competitions before. If you just keep composing, you'll get recursion because the answer of one gets plugged into itself. Then that answer gets plugged into itself. So here's a quick example. Find the first 3 iterates, x1, x2, x3 of fx equals 5x plus 4 for x sub 0 equals 2. They're trying to find f of 2. Alright, well f of 2 they found right there is 14. So this is f of 14. So now I'm going to plug in 14 to the answer. They found right there that f of 14 is 74. So this is f of 74. Plug 74 back to f, get an answer which is 374. Alright, so this is a composition. Just the answer 1 gets plugged back in right away. That's what recursive is. You must know the previous answer to move forward. Alright, I'll leave this practice problem. Find the first 5 terms of the sequence. Remember, you just plug it in and see what they are, and there's the answer. Alright, thanks for watching. See you in class. Bye.